polygon. Those are the roots that which we have been calculating. Okay. So what exactly does this mean? That means you can actually find these vertices, or you can find these vertices of this regular polygon by finding just one single vertex and rotating that point around the origin. This is equivalent to multiplying the nth roots. So it's like if we rotate this and it comes right here, then we've got z of n is equal to 1, isn't it? So once we get this, we are able to generate the other roots using the nth roots family, isn't it? So that's basically what we are saying. So we are saying if z1 happens to be one root of an equation, not this equation, of an equation probably that looks like this, not with 1, isn't it? But if z1 happens to be one of the roots, because if we rotate it, it goes to this part, isn't it? What does that mean? It means then we can find the other roots by saying the first root is z1. So the second root will be what? Will be z1 times the nth, this omega. The third root will be z1 times this omega squared, as it goes like that, because we know that the relationship that guards the omegas and 1 is when you add them, these units of roots, they give you 0. Are we together? That's basically the concept that is the last part. So it's not anything else that is complicated at all. It is just appreciating that if you've got the first root, you can use the nth roots of unit of zn to the power of 1, or to the power of n equal to 1, to generate the other roots of zn equal to a. Are we together? That's basically what they're saying here. All right. Let's look at it in perspective to an example so that you appreciate this. There is no question is that in your but you're told, imagine you're told the point lies on a vertex of an equilateral triangle. So we've got a clue that it's a triangle. So if it's a vertex of an equilateral triangle, it probably is here and here and here. It's 3 roots, isn't it? Are we together? So we know that if we find the first root, we can find the other 3 roots by multiplying the first root with the what? The unit with this value, with this value, the nth root of unit. Are we together? That's all. So basically, what do we have here? We've got P. So if P is somewhere here, let's just assume P is somewhere here. Let me draw an Argand diagram. So P is this is real roots, E, I, and then P is somewhere here. Obviously, it's in the first quadrant. Root 3 and 1 is in the first quadrant. So I can just put it anywhere I want anyway, because this is not up to scale. I can put it here. That's P. That's my P, which is root of 3 and 1. And so I can create a triangle here, isn't it? I am able to tell what is R and theta based on the understanding that this is root of 3 and this is 1. Correct? Is that so? Yeah. So if you're able to do that, what is it? Let's try to do that. Let's calculate that. What is R? R is what? R is 2. That's so fast. Okay. What is theta? It's a special angle, you're right? Is that so? It's pi over 6, isn't it? So so the first root is what? Let's call it z1, right? Z1 is going to be equal to what? Okay, I can write it as root of 3 plus I pi over 6.
Yeah, wait, yeah. in that 1 over root 3.
Root 3 plus
Is
I.
five.
It's pi over 6. Yeah. So this is the first root.
Isn't it? Oh, no.
So this is the first root. Are we together? I can write it like this, I can write it like this, or I can write it like this if I want. All right? Is that okay? I can write it in any of these forms. So how do we find the second root and the third root? Oh, we said omega. What is omega? Omega is E, go ahead, 2 pi I over 3. Yeah. Are we together? So how are we going to find Z2? Z2 is going to be equal to omega times Z1. Are we together? Which is just going to be equal to E 2 pi I over 3 times, it's better for me to use the exponent now, is it? Times 2E pi I over 6, which is equal to 2. Then can you add those two? Times 2 there. So that's 5, right? 5 pi over 6. Oh, look at me now.
So how do you get omega? So what? I was given.
It was not, yeah, but it's given, it's given, but we actually found how it is, isn't it? Yeah. We actually found it.
Okay, the proof.
Why it's like that at the beginning, isn't it? And what is Z3? Z3 is going to be equal to omega squared times Z1. So omega is that squared. So omega is going to be squared. I'm sure it's going to be 4 pi over 3 if we square it. Okay? Then times 2e pi I over 6. And then this is going to be times 2 here times 2, that's 8. 9 pi over 6. And 9 pi over 6 has to be changed. Was 9 pi over 6 is equivalent to 3 pi over 2 minus 2 pi. So it's going to be minus pi over 2. So it's going to be 2e minus pi over 2i. Those are the other roots.
Could you do Z3 equals WZ2 as well?
Of course. Why wouldn't you? Can you?
Yeah, I think so. Because W2 is.
Yeah, of course. If this, I'm going to put another omega here, isn't it? To get Z3. I'm take this one, put in, yeah, that's it. So you just do omega W2. Yeah, good observation. Yes, of course, that's it. Much easier anyway, isn't it? Yeah. All right, that's it. Can you sketch this? Yes, you should be able to sketch the other points, and then you draw a triangle and be able to calculate the area of a triangle, half base times height. Can you do that? Calculate the area.